Okay, while we were reviewing today, it was asked to have just a quick little worksheet or review on gas laws. So I created a worksheet, posted in Canvas, and then I thought I'd give you some answers. One of the issues that some people had is memorizing the names and what laws they're associated with. And so I just made up these silly things. And if they work for you, cool. Last weekend we were doing a cleanup in the coulees, and it was amazing all the junk and stuff that people sort of just dump and don't care about where it goes. Anyway, some of the things were hassocks. So gay Lusac, Lusac sounds like hassock, and so I thought Lusac, pick up your trash. And so pick, P would stand for pressure, of course, and T stands for temperature. So Gay-Lussac looked at the relationship between pressure and temperature. Boil, oh, if you get a boil, that's not very good. It's pretty vile. And so boil is pressure and volume and the indirect or inverse relationship between those two. Avogadro, the name sounds like a vampire, doesn't it? So it sounds like we're making a vampire. So M is for moles and V is for volume. So Avogadro looked at the relationship between moles and volume. And Charles, King Charles, sounds like a wealthy kind of guy, so he would have a vast amount of trees. So V for volume, T for trees. If that helps you memorize the names, cool. Hopefully it does. If you find a sort of a better way of doing that, let me know. Here's just a quick table that we can use. I guess we don't need decimals here. Quick table that you can use to think of that. So Gay Lussac, hassock, pick up your trash. So he explored the relationship between pressure and temperature and found that it was direct. In other words, as the pressure goes up, the temperature goes up. Formula would be P1 over T1 equals P2 over T2. That's his formula. So I didn't leave a whole lot of room there. Boil. Boils are pretty vile. So he explored pressure and volume. And this one is, I guess, the only one that's an inverse relationship. Because as pressure goes up, volume goes down, and vice versa. But his formula was P1V1 equals P2V2. Avogadro sounds like a vampire, so make a vampire. So he related moles, which I guess our symbol is N, not M, but moles and volume. Found it was a direct relationship. As the moles go up, the volume goes up as well. So formula for him would be N1 over V1 equals N2 over V2. And then finally, Charles sounds like a king, so he has vast amount of trees. So he related volume and temperature. Again, it was direct. Boyle is the only one that has an inverse relationship. And his formula would be V1 over T1 equals V2 over T2. Now we also have a combined gas law, that's P1V1 over T1. I guess you can put an N there too. And P2V2 over T2N2. So there's a combined gas law, not a real name that goes with that one, like a person's name. We also have Dalton's law of partial pressures. So the pressure total in a container is equal to the pressure of each gas separately added up. So that's another law that we used. We also had the last one, I think the last one was the ideal gas law, and that's one where you're not changing any pressure, volume, moles, or temperature, but you just want to know what those characteristics are for a particular gas. So you're given, say, 3 of those. You always know R, so you're given 3 and you have to figure out the 4th one. So those are a couple other laws that I didn't mention up here. I thought I'd do just a question with each one of them to show how to do them. When you're doing any of these questions, it's useful to do your P1, V1, T1, N1, P2, V2, T2, N2. and then just write down the stuff you know and the stuff that stays constant. And from that, you should be able to determine which formula to use. So it says, what volume of gas would result if you start with 225 milliliters of neon gas, and then you want to know what volume you're going to wind up with. And it's compressed from, so it starts at 1.02 atmospheres, and it ends up at 2.99 atmospheres. So they must have really compressed that about 3 times, eh? And they want to know what volume. And they say constant temperature, so temperature's a wash, and they don't say you lost any gas, so moles are a wash. So I'm just looking at pressure and volume. So that is pretty vile. Has to be Boyle's law. So P1V1 equals P2V2. We're going for V2, right? So that's what we're looking for. So V2 is P1V1 over P2. So pressure 1.02 atmospheres, times volume 225 milliliters, divided by pressure 2.99 atmospheres. So if you sort of triple the pressure, because it's Boyle's law, it's inverse. So if you triple one, you have to cut the other one in 3. So if you 225 cut into 3 is like 70 something. So that's what I'm assuming my answer will be. But let's use decimals to figure that out. So I have 1.02 times 225 divided by 2.99. 76.75. 76.7558, etc. Atmospheres cancel, so I'm left with milliliters, and that's okay. I could have converted things to liters earlier, but since the atmospheres cancel, you're left with milliliters, that's okay. 3 sig figs everywhere, so I'd call this 76.8 milliliters of neon gas. Okay. Yeah, so it's compressed, so you'd have 76.8 milliliters of the gas. It's the same amount of gas, but it's just compressed now. Okay, here's another question. So I have, let me do my P1 stuff again. V1, T1, N1, P2, V2, T2, N2. 375 mil of gas, so 375 milliliters. It's heated from 24, okay, I gotta do that. 273.15 plus 24, 297. So 297.15 Kelvin at a constant pressure. Pressure's a wash. They don't say that they're removing any gas. So they want to know what will the volume be at this higher temperature. So 273.15 plus 72. So it'd be 345. 345.15 Kelvin. Okay, so I have volume and temperature, so that's vast trees. It's got to be Charles's law. I'm liking my new way of remembering those. Vast trees. Charles' law, which says V1 over T1 equals V2 over T2. I'm searching for V2, so the formula will be this cross, V1 T2, divided by the other thing that's across from what I'm looking for, T1. So V2 is equal to volume 1, 375, times temperature 2, 345.15 Kelvin, divided by T1, 297.15 Kelvin. So volume 2, I'm running out of room. I'll have to round it as I go. Okay, decimals. 375 times 345.15. divide 297.15. Now notice that those two are just on their own like that, instead of sort of how I've written it down here. And that's okay. That's okay if they're like that. If you wanted the whole thing on top divided by the whole thing on the bottom, you could put brackets around the stuff up top. Anyway, my volume comes out to 435. Oh, I need 3 sig figs. I guess when I add the 24 to these, the real rule is you go by decimal places. No decimal places. So in your answer, I shouldn't have any decimal places here or there. So really it's 3 sig figs again. So 435.5, so 436. Rounded to the proper sig figs would be 436. Let's try another one. Okay, 2.7 grams. All right, let's do our P1 stuff. P2, V2, T2, N2. 2.71 grams of argon gas. So that's not on my list, but it's a gram. So I can change it into moles by using this formula. So mass is 2.71 divided by the molar mass of argon. I'm going to have to figure that out. Give me a second. I don't have my periodic table handy. 39.95, I think. 39.95 grams per mole. Grams cancel. And let's figure that out. So 2.71 divided by 39.95. Okay. So my moles are 0.06783, etc. Okay, so that's my moles. That goes here. 0.06783 moles. Occupies a volume of 4.21 liters. What volume will, if I change my number of moles to 1.29 moles, what volume will that, under the same conditions? So pressure and temperature both awash. So it's volumes and moles. So more vampires. That's the one, right? So it's Avogadro's law. So Avogadro's law is N1 over V1 equals N2 over V2. I'm looking for V2. Whoops. I said V2 and circled the other one. So V2 is equal to N2 V1 over N1. So N2, 1.29. Nice that they didn't make me convert that to grams too. And V1, 4.21 liters, divided by N1, 0.06783, etc. Be nice to have that whole number in there, but I guess I can write it from up there. Okay, oops. So 1.29 times 4.21, 21 divided by 0.0678347. Notice the more numbers I put in there, the less difference it makes on the actual number there. It's nice to use the whole number, but the more decimal places I type in now, it's not going to make any difference to my sig figs for this question. Okay, so it'll be 80.0607 sig figs and 3 all around, so it'd be 80.1. Let's see, this was moles, so cancel that. So this has to be liters. 80 liters. That's quite a change in space. But 1.29 moles versus 0.06 moles, that's a significant difference too. All right, last question. Determine the pressure change when a constant volume gas at 1 atmosphere is heated from 20 to 30. Okay, let's do our stuff. P1, V1, T1, N1. Determine the pressure change when you're starting at 1 atmosphere and they want to know what the new pressure is. I guess they want the change in pressure, but we'll give them the final pressure, and then if we want, we can subtract it. But you're heating it from 20 to 30, so 273.15 plus 20.0. Okay, 1 decimal place, so this would be 293.15, but for 1 decimal place, I could call it 293.2. The rounding there for the temperatures doesn't make a huge impact in the final answer, but if we wanted to do it according to the rules, that's what it would be, Kelvin. Okay, and then I go to 30, so it's got to be 10 more than that, so it'd be 303.2 Kelvin. Assume no volume change, constant volume, and we're not putting any more gas in or taking stuff out. So this is P and V. That's Gay-Lussac's law. So pick up your trash. P and T, pick up your trash. Lussac, Hassick. Boy, I think I've got those memorized. So the formula would be P1 over T1 equals P2 over T2. I'm looking for P2. So it's P1 T2 divided by T1. P1, 1 atmosphere, times T2, 303.2, divided by 293.2 Kelvin. That's T1, yep. Kelvins cancel, my answer would be in atmospheres. I just happen to have a calculator right here. So 1 doesn't make any difference. So it would be 303.2 divided by 293.2. There we go. So the and we need to go to 3 sig fig, so it'd be 1.03 atmospheres. So if you crank the temperature up from 20 to 30, not going to change the pressure a whole lot. Okay, hopefully that gives you a nice little review and instruction on those 4 main gas laws. If you do have questions, always give me a text. I can help you.